Most of us have been affected by cancer, either directly or through a loved one. The key to fighting cancer is to remove it entirely. That might sound straightforward, but as a physician, it's not that easy. And actually, the way that we do things is not really fair for patients. Let me show you what I mean using breast cancer as an example. In the amount of time it took for me to go over that last slide, a new patient has since been diagnosed with breast cancer. Let's follow her journey. The first step is to undergo surgery in the operating room. Here, the surgeon removes the tumor and sends it for tumor margin analysis, which is where they stain the tissues and look at things under the microscope to make sure there's no residual cancer. But this process can take hours to days. Meanwhile, back in the operating room, the surgeon will close the patient up. The patient will then go home without knowing whether or not her tumor has been fully removed. A week later, she'll get a call from the surgeon with the results. If the margins still contain cancer, then this whole process has to happen all over again. The lack of real-time tumor margin information is why 25% of patients have positive margins the first time around. It's also why 10% of patients require 3 or more surgeries before finally getting clear margins. This is a huge problem, and we're the team to solve this problem. Our core team are experts in surgery, immunostaining, and synthetic biology. Together, the five of us have more than 25 patents, a third of which are licensed for use. This current technology comes out of the labs of Professor George Church and Professor Jim Collins. My name is David Lee. I'm a resident physician at Harvard. I want to introduce my colleague, Elena, who has, she spent her entire PhD at MIT building the same types of assays that we are here to replace. Take it away.
Thank you, David. So these images show what a tumor looks like. And as you can see, it's very difficult to distinguish the tumor margins in yellow without doing immunostaining, which is the image you see on the right. So immunostaining takes time because it has many complicated steps, so it cannot be used during surgery where time is of the essence. Our solution is the patent-pending Sparkle Instant Nanosensors. We have combined the accuracy of immunostaining with an instant readout through a novel mechanism. We use conditionally fluorescent molecules, and we attach them to protein binders, such as nanobodies. The nanobody complex is highly specific to its target, such as the tumor protein, and when it binds, it glows, resulting in an instant signal. Our sensors do not require washes, so they can be used at the point of care. Here you see one of our sensors rapidly turning on and glowing once it finds its target. We hold patents for every single step of the process. This includes composition of matter patents for the conditionally fluorescent molecules, as well as methods for their use. We have already developed more than 10 sensors, and it takes us 3 weeks of research to develop a new one. And our sensors are instant, so that means that the assays that used to take days now take milliseconds.
Current technologies require a trade-off between speed and accuracy. We have bypassed this problem entirely by reinventing the mechanism of how immunostaining can be performed. This is why Sparkle is a platform technology that has numerous indications for both research and diagnostics. Our beachhead market will be breast cancer surgery in the United States. Capturing 10% of this market will yield an annual revenue of $11 million just from one disease. We plan to replicate this across other diseases in our pipeline, which is why we're looking at a total addressable global market of $50 billion. To date, we have engineered more than 10 sensors for 5 different diseases. In addition, we have conducted more than 100 interviews with key stakeholders, more than 90% of whom said they would purchase this technology when it's out on the market. We hope to utilize $100,000 to further refine the performance of our sensors in patient tissue samples acquired from regional biobanks before getting FDA approval. So let's go back to our patient before we end. We think this loop of uncertainty is not fair for any patient to go through. With our Sparkle technology, we can have confirmation of margin clearance during the surgery so that the patient can go home knowing that her cancer has been fully removed. With that, we are Sparkle Biosciences. I hope you'll join us in lighting up cancer, one tumor at a time.